Greetings, friends of chemistry. Martin and I are doing the Module 13 review questions found on page 456.
456.
All right, so Martin,
My God.
please read me the first question.
In a chemical reaction, where is the potential energy? Where is the kinetic energy?
Okay. So how would you answer that? The potential energy
is in the reactants.
Yeah, where is it stored?
In the
What do we have to draw?
bonds?
We have to draw the Lewis structure so we can see the
bonds.
Bonds.
I said bonds.
I didn't hear you say it. It's in the bonds. So the potential energy
and so the kinetic energy is when the bonds break.
Or kinetic. It's either stored or released, right?
Yes.
In chemical reactions. You could say absorbed. Okay, so potential energy is stored in the bonds. Kinetic energy is either stored, absorbed, or released in chemical reactions. And that will seem to be, what would we call that? We'd either call it
an exothermic or endothermic
right.
reaction.
So if it's absorbed or stored, it gets
cold.
And if it's released, it gets
hot.
Right. Okay. So number
2.
Please read it.
If a chemical reaction has a positive delta H, will the beaker that contains the reaction feel hot or cold once the reaction is finished?
Okay. What do you think is the answer to that? Yeah, so if it has a positive delta H,
that means it's an endothermic reaction.
That does mean it's an endothermic reaction.
Cold.
Good.
Why 3? Are we going to 3?
Uh-huh. Go ahead.
Why is Hess's law a more exact way of determining delta H than the technique that uses bond energies?
How does Hess's law operate, right? So it says enthalpy is a state function and is therefore independent of path. What does state refer to?
It's a quantity that depends solely on the final destination, not on the way you get to that destination.
Well, what do we mean by the state? Do we mean like if President Obama goes to a state dinner, that has a specific.
Exactly what we mean.
Exactly. That has a specific diplomatic meaning, which is not what we mean in chemistry. In chemistry, what are we talking about? We're talking about the states.
Yes.
We're not talking about the states of the U.S. We're talking about what are we talking about? I said.
The state of
the state of the matter. So yes. What state can it be in? It can be
solid.
Liquid, it can be liquid.
Gas,
it can be gas.
Plasma.
Yeah, but we're not working with plasma in this course, as you know.
Plasma
so we work with things that are aqueous, solid, liquid, right? Aqueous means dissolved, right? Uh-huh. So Hess's law
the enthalpy of formation
is different, right? Because in Hess's law, we're taking into account the phases of the substances. Mm-hmm. Okay?
Yeah.
So when we say it's a state function, we're talking about what phase it's in. Yeah. All right. So Hess's law is more exact because it takes into account those states. So I'm going to pause here and we'll come back with another video for number 4.